Everyone, welcome back. Today we are going to study about uniform circular motion. Equation of motion, they completed. There are 3 equations of motion that we have done in last lecture. Today we are going to do uniform circular motion. But before that, more thing I want to tell you about this distance time graph. Let's say you have 3 data. Now simply by looking data you cannot tell which body is moving faster. Let's say this blue one is for A, middle one is for B, and last one is for C. Simply by seeing data you cannot determine which is faster, and it will take time to calculate and see. This thing we can easily do by simply observing graph. So let's suppose the graph of this 3 table is like this. Now if you see these 3 A, B, C lines, they have different slope. Now slope means their steepness, how their inclination from horizontal direction. More inclination, more fast that object is. So if you see that your C is having less inclination as compared to B. Similarly, B is having less inclination as compared to A. This A is having more steepness. So A is fastest, then B, and then C. So simply by observing this slope, you can compare between two bodies which is moving faster, and this is possible only in case of uniform motion. Now coming to uniform circular motion. As you know, what is acceleration? It is change in velocity, and velocity is your vector quantity. Vector quantity means velocity is having magnitude and direction both. Now change in any one of the thing, either if I change magnitude, then also it will give you acceleration. If I change direction, then also it will give you acceleration. So out of magnitude and direction, change in any one of the thing will change in acceleration also. Now what we are going to do here is, we are keeping magnitude same. That means velocity of constant magnitude, but direction we are going to change. That means let's say a body is moving, it is always moving with 10 meter per second, and now we are changing direction. Now how we are changing direction? Let's say a boy is moving on a rectangular track. If he is suppose standing over here, now to keep its velocity constant, in the 4 corners he has to change direction, right? And the 4 corners where he changes direction, acceleration, he is going to accelerate. Though will keep its speed constant, but to keep pace with the running speed, at the corners he has to change direction, its acceleration will be there. Similarly, instead of rectangle, if I have a, let's say hexagon, that means when you have 6 sides. So when a boy starts from this direction, now at 6 corners he has to change direction to keep in pace with its constant speed. So as such, if I keep on increasing side, then change in direction will also keep on increasing, and if we keep on increasing size, in the end what we will get is a circle. So in a circle, at each and every point the body is changing its direction. Though the speed is constant, but it will be considered like at every point direction is changing. That means there is change in acceleration. So what you can say is, if a body is moving in circular path with uniform speed, then its motion is called uniform circular motion. Though the motion is accelerated, now here motion is accelerated because at every point of circle this body is changing its direction. So uniform circular motion, when a body moves in a circle, it is called circular motion. When a body moves along a circular path, then its direction motion keeps changing continuously. So uniform circular motion, a body moving in circular path, its speed is constant, but at each and every point it is changing direction. That's why it is having accelerated motion. So now if I write this in terms of formula, we know that circumference of a circle of radius r is given by 2 pi r. Circumference of a circle is 2 pi r. So if let's say an athlete is taking t seconds to complete one circular path. So velocity is distance upon time. Distance here is equal to, if let's say this is your circle, so distance here is equal to this circumference of this circle divided by time. So 2 pi r divided by t. Few more examples of this uniform circular motion is motion of moon and the earth, then a cyclist on a circular track. Now in your course you have only elementary introduction of this uniform circular motion. More about it you will study later on. So this is your end of this chapter 8th.